All right, class, from your outline, we're going to be looking at Chapter 5, number 26. It's on the second page of your outline. It says some IQ tests are standardized to a normal model, mean of 100, standard deviation of 16. So I wrote that down, mean of 100, standard deviation of 16. Draw the model for these IQ scores and clearly label it, showing what the 68, 95, 99.7 rule predicts about the score. So from our previous notes, I drew that 68, 95, 99.7 rule as the normal model right here. You can either copy and paste this or draw it on your own. And what I'm going to find here is at 0, it is 100, right? Because remember, the average should be right in the middle at 100, like that. And 68% of the data is in this purple right here. And the thing about that is it's completely symmetrical, and we'll get to that in a second, but let me show you one standard deviation to the right. Since the standard deviation is 16, would be 116, and another standard deviation to the right would be 16 more, which is 132, and another one to the right would be 16 more, which is 148. So remember, 68% of your data is within one standard deviation on each side. 95% of your data is within 2 standard deviations, and 99.7 is within 3 standard deviations on both sides. So let's get the left side here. We start at 100. One standard deviation to the left would be 100 minus 16 is 84. Another standard deviation to the left would be 68. 84 minus 16. And then another standard deviation would be 68 minus 16 is 52. So what interval would you expect the central 95% of IQ scores to be found? That central 95% is 2 standard deviations. Remember, the rule says 2 standard deviations for 95%. So that would be between 68 and 132 for 95% of IQ scores. Now, this next one is a little trickier. The percent of IQ people, what percentage of people should have IQ scores above 116? Yeah, so to calculate the rest of these, I need to figure out what the percentages are on what percent of the data is in these different shaded regions, right? Look, most of it's in the purple, right? And it's 68%. But the interesting thing about this, since it's chopped symmetrically, perfectly symmetrically, 34% is this part of the purple, and 34% is that part of the purple right there. So it splits into 34 and 34. Now I want to figure out about what these pink is. So purple is 68% of data, 34 on each side, 34% each side. Now, to figure out pink, I have to remember that purple and pink are 95% of data. From here to here, on our rule, 2 standard deviations both directions is 95%. So that would be 95% of our data, but the purple takes up 68 of that 95, right? So 95 minus 68 would be the pink. And that is 27% of data. And it would be half of that on each side, 13.5% each side. So each of these pink ones are 13.5%. 13.5%. Now the red is 99.7% of all stuff is in between the purple, pink, and red, right? Between the 3 standard deviations from 52 to 148. But we've already taken account 95% of it, so minus that 95%, and we get what? On this one, we get 4.7% of data is in the red, and 2.35 on each side. So I just take it and divide by 2. So 2.35 here, and 2.35 here. So 99.7% of data is from this 148 to 52. But what about the ones that are below 52 and 148? They're extremely rare, but they exist, right? So no color on the outside would be, the whole thing is 100% minus 99.7, 3% of data. 0.3%, my bad. 99.7 would be 0.3% of data. So 0.15% on each side. So off the three, after the 3 standard deviations, is 0.15% of all data. So after the 3 is 0.15% of all data. So I figured out all my shadings by doing a little math there. And so what percentage of people have IQ scores above 116? So we go to 116 right here. What percent are above that? 13.5 plus 2.35 plus 0.15. All the different shadings above 116. 13.5, 2.35, 0.15. And so let's add those. And when I add those up, I get 16%. So 16% of the scores are above 116, which means 84% of people were below it, which is a pretty good score for IQ score. So the next one is about what percentage of people have scores between 68 and 84. Let's look at those. 68 to 84 is from here to here, and that is 13.5%. And then the last one is what percentage of people have scores above 132 at the 2 standard deviation mark. Now remember, this should make sense to you. It's going to be 2.35 plus 0.15, and that's 2.5%. Whoops. And that is 2.5%. But let me show you another way you could have gotten it. Because 132 is at the 2 standard deviation mark, and 95% of data is between here and here, between 68 and 132, which means 5% of the data is on the outside, which is 2.5 in each direction. 2.5% would be above 132, 2.5% would be below 68. See, that adds up, 2.35 plus 0.15. So that is number 26 from chapter 5.